Hello and welcome everyone to Infinity Learn by Sri Chaitanya, and I'm Ravindram. Today I'll be discussing the physics portion of the AIIMS Physics LTC exam unit test 6. Okay, so let's begin with the first question, students. Two insulated charged spheres of radii R1 and R2 having charges Q1 and Q2. Okay, let's say R1 charges Q1. Suppose they are being connected through a wire like this. Okay, and this is a switch. This is radius R2 and the charge on this is Q2, right? Now the thing is, what will happen if you close this switch? If you close this switch, then definitely, if there is any potential difference, like suppose this is potential V1, this is potential V2. So if there is any delta V, then obviously some charge will flow from the sphere of higher potential to the sphere of lower potential. And if the charge movement is there, then obviously there is electric current, and if there is electric current, there is definitely heat loss in the form of resistance. Okay, so overall energy of the system will definitely decrease. So if there is any potential difference, there will be current and there will be overall reduction in the energy of the system. But if the potentials are same, that means if delta V is 0, then there is no current and there is no heat loss. No heat loss, that means energy of the system remains same. But how we can say? See, potential V1 is what? Q1 by C1, and this must be equal to potential V2, which is what? Q2 by C2. So what is Q1 by what is C1? 4 pi epsilon naught R1. This is what? Q2 upon 4 pi epsilon naught R2. Okay, from here we can say that Q1 upon R1 must be equal to Q2 by R2. Under this condition only, there will be no decrease in the energy of the system. So fourth option is correct. Got it? Now, a hollow metal sphere of radius 5 centimeters charged. See, it is a hollow metal sphere. Hollow metal sphere means the potential everywhere inside the sphere will remain constant. So whatever is the potential on the surface, that same potential will remain everywhere inside. So even at a distance 2 centimeter inside, the potential will still be 10 volts. So second option is correct. If the potential on the surface is 10 volts, inside at every point also the potential will remain 10 volts. Got it? Now, a charge Q is placed at the center. Okay, this is a cylindrical arrangement like this, right? And a charge Q is placed here. So if we want to find out what is the flux through the cylinder, what we will do is we will draw a similar dimensional cylinder like this so as to encompass this charge, and in such a way that this charge is at the geometrical center of the overall structure. Now this is an overall cylinder and this charge is now at the geometrical center of it, so that we can say overall flux through this complete closed surface is Q by epsilon naught. Now this flux is divided into two identical cylinders. Symmetrically, whatever the flux goes through here, same flux will pass through this cylinder also. So flux through one cylinder will be Q by 2 epsilon naught. Do you understand? So third option is correct. Let's go to fourth option. See, electric dipole, what is the formula of potential energy? It is minus vector P dot vector E. This is the formula of potential energy. So it is minus PE cos theta. So if you want to find out at which point U is minimum, minimum value is minus PE cos of 0 degrees, right? So it is minus PE. This is U minimum. So we will say that cos 0 is 1, right? So 0 degrees is correct. Fifth question. The capacitance of a parallel plate capacitor. See, capacitance is epsilon naught A by D. So it depends upon permittivity of the medium, area of the plates, distance between the plates. Area, medium between the plates, distance between the plates. So what is left is metal. It doesn't depend upon what kind of metal you use. Okay. So does not depend upon metal, right? Question number 6. This is a simple formula. What is the force of attraction between the two plates of a capacitor? Always remember the force of attraction is Q square by 2A epsilon. So you can say it is Q square by 2A K epsilon naught. K is the dielectric constant of the material or medium in between the plates. Okay, this is the formula that you have to remember. You can't do anything about it, right? Now, in the circuit shown in the adjoining figure, the resultant capacitance between P and Q. See, 2 and 3 are in parallel, so they will be directly added, so they will become 5. So it will become 12, it will become 5, and it will become 20. 12, 5 and 20. So what you will do, you will say, sir, 1 by 12 plus 1 by 5 plus 1 by 20. This will be your 1 by C equivalent. Use the formula, get your right answer. Okay, clear? So answer will be 3 microfarad on solving it. Question number 8. A 4 microfarad capacitor is charged to 400 volts and then its plates are joined through a resistance of 1 kilo ohm. The heat produced in the resistance. See, it's very simple logic. That if you charge a capacitor, first of all, now if you connect these ends of the capacitor, okay, if you connect these ends of the capacitor, then what will happen? All this charge will drain from this particular plate and will move to this plate, such that the final potential difference becomes zero. That means whatever energy is there on the capacitor plates gets completely converted into heat in the form of resistance. So you will say, what is the heat loss? So you will say, it's very easy, half CV square. So half into 4 microfarad into potential difference is 400 whole square, normal. Now you solve it, you get your answer. Fourth option will be correct. Okay, question number 9. Okay, we know what is the formula of common potential. C1 V1 plus C2 V2 upon C1 plus C2. Now you tell me, what is C1, what is V1, what is V2? 0. So which option is correct? C1 V0 upon C1 plus C2. Second option is correct. Okay, here, what is current? It is dq by dt. So just differentiate it with time. 4 into derivative of t cube is 3t square, plus 5 into derivative of t is 1, plus derivative of 6 is 0. So 12t square plus 5. You put t equals to 1, I will be 17 amperes. Got it? Second option. 11th. The quantity is at whenever the cross section of the wire changes, okay, the current remains constant. Remember this thing. Okay, because I is what? NEAVD. N and E will remain constant. So we will say A1 VD1 is equals to A2 VD2. Right? Yes or no? So I remains constant. This you remember, no matter what happens to the cross section. So current only. Otherwise everything will change. If area changes, drift speed changes. So current, electric field and drift speed, wrong. Drift speed only, wrong. Current and drift speed, wrong. Only current remains same throughout. Now, see, this is a question which has been asked in previous exams also. So I'm going to discuss it once again. Copper is a conductor. Germanium is a semiconductor, right? So if you reduce the temperature, resistance of a conductor reduces and resistance of a semiconductor increases. Do you understand? So copper decreases and germanium increases. Clear? Now question number 13. So here obviously delta V by delta I is the slope and this is also the resistance. And we know that resistance is directly proportional to temperature difference, right? So if T1 is greater than T2, then obviously this slope represents resistance, right? So T1 is greater than T2, simply R1 is greater than R2. Okay, since the slope for this line is greater and hence the resistance for this line is greater and hence the temperature for this line is greater, so first option is correct. Got it? Now here what they have said is the figure shows, okay, see, whenever you take an EMF like this, sorry, whenever you take a cell like this is point A, this is point B, and this is EMF and this is internal resistance and this is the current, right? So we say that VA minus VB which is the terminal voltage, is equals to EMF minus IR when the battery is getting discharged, right? So initially we are saying when current is 0, so delta V must be equal to EMF. That means this value is EMF, that is what, 1 volt. Now what they need is, let me check. Okay, so what they need is they want to find out the internal resistance also. Now here when delta V is 0, see, when delta V is 0, then EMF minus IR is 0, then EMF is equals to IR. So what is internal resistance? EMF upon I. So what is EMF? 1 volt. What is current right now? 4. So what is the answer? 0.25 ohms. So first option is correct. Got it? Now, if a given volume of water is 220 volt, heater is boiled in 5 minutes. Okay. If a given volume of water in a 220 volt heater, what is the delta H? See, delta H is power into delta T, right? Power is V square by R into delta T. Now heat supplied is same. So you will say, if you say 220 whole square by R into 5 minute must be equal to 110 whole square upon R into delta T. We don't know how much it is. So if you solve it, R and R will get cancelled because the resistance will remain same for the coil. So delta T will definitely become 4 5s or 20 minutes. Got it? Question number 16. See, monochromatic light. So whenever we study about photoelectric effect, students, one thing is very important, that here intensity is given by number of photons striking per unit time into energy of a single photon. That means intensity is number of photons striking per unit time into energy of a single photon. This is how we represent intensity when we are talking of light to be of particle nature. This is very important, right? Now they have given us the frequency, they have given us the power. So number of photons emitted on an average, they are asking, okay, per second. So intensity is given, or power is given, right? Power is what? Intensity into area. Have they given anything about area? Acha, sorry, I'm so sorry. Upon area also. Upon area also. This is intensity. So intensity into area is power. Okay. So power is technically this much only. Delta N by delta T into H nu. Got it? Now power is given to us 2 into 10 to the power minus 3. So delta N by delta T, number of photons per second. Now what is H? 6.626 into 10 to the power minus 34 into frequency is how much? 6 into 10 to the power 14. Now everything is given. You just put the values and get your right answer. Is it okay? Yes or no? So you can say this like this. See, 2 ones are 2 threes are. So 10 to the power minus 3 is equals to delta N by delta T. Now 6.626 you can write like 20 by 3. So into 10 to the power minus 34 into 3 into 10 to the power 14. Now 3 ones are 3 ones are. Now I guess we can solve it from here and definitely this answer will come out. Okay? Clear? Any doubt? Now, this is very interesting. See, when I talk about a point source, suppose this is a point source. So what is happening? The light is going in all the directions, right? The light is being covered in a complete sphere. Everywhere the light is going. Okay. So we can say that the power remains constant. But intensity is what? Intensity is power per unit area. So technically, intensity is power upon 4 pi r square. This is r, right? So intensity is inversely proportional to r square. And we know that in photoelectric effect, the current depends upon the intensity. If the intensity reduces, so number of photons per second reduces, so the saturation current reduces, but the stopping potential doesn't change. So if you are changing the R, that means from R you are making it 3R, right? So intensity reduces 9 times, because if R becomes 3R, intensity becomes from I to I by 9, and similarly the current will also become from I to I by 9. So what is the answer? Second option is correct. Stopping potential will not change. Stopping potential changes if the energy of a single photon changes, right? But if you change the intensity of the light, that doesn't change the energy of the photon, that changes only the number of photons striking per second. And if you reduce the number of photons striking per second on the plate, then automatically the photoelectric current or photocurrent reduces. Clear? Now, the energy that should be added to an electron to reduce its de Broglie wavelength from 1 nanometer to 0.5 nanometer. So what is de Broglie wavelength? And what is momentum? Root over 2 mk. K is kinetic energy. So if you want to make it lambda by 2, then it is 2m k dash. So if you take the ratio, so k dash will become 4k, right? K dash will become 4k on taking the ratio. So what is the extra energy that is to be given? K dash minus k. That is 4k minus k. Delta k becomes 3k. Got it? So that is why thrice the initial energy is the answer. The distance of the closest approach. See, it's very easy. The loss in kinetic energy will be equal to gain in potential energy, right? Gain in potential energy. So whatever is the kinetic energy. So the distance of closest approach, if it is okay, so K is direct. What is potential energy? Potential energy is Q1 Q2 upon 4 pi epsilon naught R. That means kinetic energy loss is directly proportional to the distance of closest approach. So if you double the kinetic energy, the distance of closest approach will become half. Yes, because R is inversely proportional to kinetic energy. So if you say instead of K, if you take 2K, then R becomes R by 2, because they are inversely proportional. Do you understand? So third option is correct. Third option is correct. Question number 20. The electron in a hydrogen atom jumps from ground state to the higher state where its velocity reduces to 1/3 of its initial value. See, what is the formula of velocity? It is 2 into 10 to the power 5 into z by n, or we can directly say that velocity is directly proportional to z by n, right? It is directly proportional to z by n. So if velocity becomes 1/3, that means n is equals to 3. So it goes to the state where n equals to 3, right? Now, if the radius of the orbit in the ground state is r, the radius of the new orbit will be, see, radius is directly proportional to n square by z, right? So if n becomes 3 times, radius becomes 9 times, right? So radius will be 9r. The new radius will be 9r. Do you understand? Because from first orbit it moves to third orbit, and radius is directly proportional to n square. So if n changes from 1 to 3, n square changes from 1 to 9. So radius changes from r to 9r. Do you understand? Hence, second option is correct. You need to remember these things, students. How velocity depends upon z and n, how radius depends upon n and z. Do you understand? These things you need to remember. Okay. Now 21. The binding energy. See, it's very easy. Q value is equals to binding energy of the reactants minus binding energy of the products. That's all. So what is the binding energy? Achha, per nucleon they have given, right? So what is the binding energy per nucleon of lithium? Achha, reactants, what are the reactants? Lithium. Hydrogen will not have any binding energy. Why? Because it's a single proton, so there will be no mass defect. So we will say 7 times 5.6 mega electron volts minus, there are 2 helium nucleus, so 2 into 4 times 7.06 7.06 mega electron volt is the binding energy per nuclei of the helium. Mega electron volt. This value will give you this is the Q value, right? So 8 into 7.06. Am I getting mistaken anywhere? Hmm, lithium. Mm-hmm. Mm-hmm. So this you can do and get your right answer. Okay. Binding energy of the reactants minus binding energy of the products. Hmm. So from here you can definitely get your right answer. Okay, no problem. Brilliant. So let's move ahead. The function of a moderator is to slow down the fast moving neutrons. This everybody knows. Which of the following is incorrect? See, nuclear forces do not depend upon charges. So they are charge dependent. This is a wrong statement. Okay. That is what we are looking for. Wrong statement. Now this is interesting. See, T represents a point which has high binding energy per nucleon. Right. So binding energy per nucleon. So T represents the highest. So obviously every element will try to achieve T, try to move towards T. So definitely X and Y will try to fuse and move towards T. So there's a possibility X plus Y will become T. So this is a possibility. And definitely Q and L, or Q will try to break itself to move towards T. So Q is a heavy nuclei. So Q might break into T plus L. So see, if I talk about, if you remember this graph, so I will tell you a little bit about this graph. This is the graph of binding energy per nucleon versus the atomic mass number, right? So this graph was like this. So this was for iron, Fe, okay, which has got the 5626, which has got the highest number of binding energy per nucleon. So every element on the left hand side of that means these elements, they try to fuse to move towards the higher value of A, and these elements, they try to show fission or they break in order to achieve the lower value of A, which is near to the iron. Okay, so every element is trying to move towards iron. Do you understand? So we can say that it is Q is T plus L. So 25. Two radioactive nuclei X and Y initially contain an equal number of atoms. So let's have a look in this question. See, there are two things to understand. One is, what is the formula of activity? The formula of activity is either this A naught into e to the power minus lambda T, or it is A naught upon 2 to the power number of half lives, right? A naught is what? N naught into lambda upon 2 to the power n is the number of half lives. So this is the formula that we will be using. Okay. Now let's move ahead and say that Ax upon Ay. See, initially concentrations are same, so there is no problem. Nx upon 2 to the power nx into n naught into lambda of y upon 2 to the power n for y. Okay, so ax upon ay will be equal to, see, lambda x upon lambda y into 2 to the power, right, 2 to the power ny minus nx. This is the answer, right? Now we need to first of all find out, see, one thing is very much clear, that lambda is equals to ln 2 upon t half, right? So lambda x upon lambda y will be equal to t half of y upon t half of x. So what is lambda x upon lambda y will be equal to 2 is to 1. Do you understand? This is how much? This is 2 is to 1. Now we need to find out what is ny and what is nx. So students, allow me to write it here. See, total time is 2 hours, right. So nx is equal to, see, half life for x is 1 hour. So in 2 hours, how many half lives are there? Two half lives. And for y element, half life is 2 hours. So in 2 hours, how many half lives are there? One half life. So nx is 2. So we will say that this is 2 is to 1 into 2 to the power 1 minus 2. That is 2 upon 1 into 1 upon 2. Answer is 1 upon 1. Do you understand? So this is how you will get the second option. So this is a very interesting question. Question number 25. Now let's move on to question number 26. It's very logical that in forward bias, diffusion current dominates, and reverse bias, drift current dominates. It's a logical understanding, right? Now in this question, obviously this is point A, this is point B, and this is forward biased PN junction. It will allow the current. So you will say, sir, VA minus VB upon R is equals to I. That's all. So it is 4 minus 1 upon 300. That is 5 upon 300. So whatever it is, the answer will come out. Okay. Ampere, you want to convert it into milliampere, this will be the right answer. Now, a brass rod, okay, so here you don't need to do anything, everything is given to you. You just have to find out overall change in length. See, delta L is equals to F into L upon A into Y. So they have given the length, they have given the diameter, right? Change in length of the combined rod at 250 degrees centigrade. If the acha, okay, if the original length, simple, see, change in length delta L is equals to L alpha delta T, right? So delta L for brass plus delta L for steel is equals to length of brass into alpha for brass plus length of steel into alpha for steel into delta T. Do you understand? Everything is given to you. So the length is given for brass, okay, same length. So steel, for steel also length is same, diameter is same. What is the change in the length of the combined rod? Delta T is given. Acha, delta T is 250 minus 40. Alpha for brass, alpha for steel, everything is given to you. Just put the values and get your answer. Okay, clear? Now, question number 29. See, one thing about water is its anomalous expansion, that the minimum volume of water is at 4 degrees centigrade. Sorry, at, yes, at 4 degree centigrade, its volume is minimum. Okay, so if you increase the temperature or reduce the temperature from 4 degrees centigrade, in both the cases the volume increases. Okay, so if you completely fill the beaker with water at 4 degrees centigrade, so either you reduce the temperature from 4 degrees centigrade or you raise the temperature from 4 degrees centigrade, in both the cases the volume is going to rise and the water is going to overflow. Okay, so fourth option is correct. Question number 30. There are two ideal containers joined by small pipes. See, in these kind of questions you have to see that the overall number of atoms is not going to change. Okay, total moles of the atoms will not change. So initially it was P naught, V naught, T naught. So these are the number of moles, P naught, V naught, T naught. So overall, what is the initially number of moles? P naught V naught upon T naught plus P naught V naught upon T naught. On next time the pressure will become, next time the pressure becomes P and P, temperature becomes 2 T naught and T naught. Volume remains V naught and V naught, it is not going to change. So you're going to write like this: P V naught upon 2 T naught plus P V naught upon T naught, right? So it will be 2 P naught V naught, 2 P naught V naught upon T naught is equals to, how much it is? 3 by 2 P V naught upon T naught. Do you understand? So this is gonna get cancelled, cancelled, cancelled. So P will be 4 by 3 P dot. Do you understand? So this is how you get your answer. Clear? Question number 31. Now, when temperature of a gas filled in a closed vessel means volume is constant. So if volume is constant, P is directly proportional to temperature. So P2 by P1 is equals to T2 by T1. Now what they are saying is P2 is 0.4% more. So P2 is P1 plus 0.4 upon 100 P1 upon P1 is equals to T1 plus 1 degree centigrade upon T1. So initial temperature they want to find out. So it will be 100.4 upon 100 is equals to T1 plus 1 upon T1. So from here we can solve and get the right answer. Is it okay? Yes. Acha, they have written increased by 1 degree centigrade. So that means this is delta T. So delta T 1 degree centigrade or 1 Kelvin, doesn't matter, both are same. Okay, during temperature difference degree Celsius and Kelvin scales are same, so there is no problem. Now you can solve it from here, and definitely you can see that T1 is coming out to be 250 Kelvin. The temperature will definitely come out to be Kelvin. Temperature will not come out in degree centigrade. This is the difference that you are putting here. That is by whether it is 1 degree centigrade or 1 Kelvin doesn't matter. Okay, but final answer should come out in Kelvin only. Okay, so this is important because they have given 250 degrees centigrade also, but this is wrong. The temperature in this formula is always, this is always in Kelvin. Okay, right? But don't need to convert this 1 degree centigrade into Kelvin, because change, this is an increment of 1 degree centigrade now. So increment of 1 degree centigrade or increment of 1 Kelvin is same thing. So either you write plus 1, you can see this, is simply say 1 Kelvin plus 1 Kelvin, not 1 degree centigrade, plus 1 Kelvin. So automatically your answer will come out to be in Kelvin. Is it okay? 32. Now this is a simple formula, m2 minus m1 upon m2 plus m1 into G is equals to A. So every value is given, you just put and get the right answer. Okay. 33. See, this is a very important formula. What is force? Force is delta P by delta T. Sometimes it is also written as delta N by delta T, that is number of bullets fired per second into change in momentum of a single bullet. Now delta N by delta T is given small n right now. So answer will be MNV. But the thing is time is given per minute. So you have to put 60 seconds here because your answer should be, the denominator should be in seconds. So the force will be MNV upon 60. Got it? 34. The kinetic energy of the molecules of a gas per liter. See, we know that kinetic energy is equals to 3 by 2 PV. So kinetic energy per volume is 3 by 2 P. So it is given 300 joules per liter. Per liter, 1 liter is what? 10 to the power minus 3 meter cube. Now it matches 3 by 2 P. Now you solve it. Obviously P comes out to be how much? 2 into 10 to the power 5 Newton per meter square. Accurate answer. Okay. 35. At what temperature will oxygen? See, what is the formula? Root over 3 R T by m naught. So temperature for oxygen will be, oxygen is what, 32 grams. It is 3 R into temperature is 200 Kelvin upon what is the mass of hydrogen gas? 2. So temperature is 16 into 200 Kelvin. So it is 3200 Kelvin. So temperature will be 2927 degrees centigrade. Got it? Now what is electric field? Electric field is minus dV by dx. So it will be minus into 10x plus 10. Simply put the values, get your answer. Answer is minus 20. Okay. This is the formula. Two positive charges are okay, fine, fine. So initially they were at 10 centimeter, now they are brought into, see, work done is change in potential energy. So it is K Q1 Q2, okay, into 1 by R2 minus 1 by R1. That's all. So put the values. 5, see what is K? K is 9 into 10 to the power 9 into 12 into 10 to the power minus 6 into 8 into 10 to the power minus 6 into 4 by 100 minus 100 by 10 by 100, because it was in centimeter we need to convert it into meter. This is how you will get your answer. Okay, clear? I suppose you have understood now. So let's move ahead. 38, this is an interesting question. Two capacitors are given. One is 1 microfarad, another one we don't know how much it is, but we will say it is C microfarad. It is 120 volts. It is how much? It is 120 volts. This is positive, this is negative, right? This condition is given. The charge on the combination is 80 microcoulombs. So obviously Q minus Q, Q and minus Q. So overall what is the charge? Q is 80 microcoulombs, right? So what is the energy stored in the capacitor of C microjoules? Very simple. First of all, we'll find out C. See, Q is equals to C equivalent into V. So 80 microcoulombs is equals to 1 into C upon 1 plus C into 120. This is also in microfarad, so micro will get cancelled, there is no issue. So you will say 80 is equals to 120 C upon 1 plus C. 42 is 43 is, so it will be 2 plus 2C is equals to 3C. So C is equals to 2 microfarad. Got it? What is C? C will be equal to 2 microfarad. Now C, you know what is 2 microfarad? So you will say the energy stored will be Q square by 2C. Now put the values. Q is how much? Q is 80 whole square upon 2 into C is 2. So there is micro coulombs square and denominator is microfarad. So 1 micro will get cancelled. Minus 6 joules. This is how your answer will come out to be in joules. Okay, clear? So answer is second option correct. 39. See, this is a very simple formula. I is equals to NEAVD. Everything is given. I is given to you. Area is given to you. N is given to you. Electronic charge we know. So what is drift speed? I upon NEA. What is drift speed? I upon NEA. Do you understand? 40. Now this is an interesting question. See, this is a diminishing circuit. See, 2, 4 and 2 in series will become 8, right? So it will be like this. See, like this. If this is 8, this will become 8. This is 2 and this is 2. Again 8 and 8 will become, see, 8 and 8 will become 4. Okay. So this will be 2, 4 and 2. Again it will become 8, right? So finally you will say it will be 3, it will be 8 and this will be 2. 3, 8, 2 will become, sorry, not 8, 4. So 3, 4 and 2 will become 9. And so overall you will say R equivalent is 9 ohms. So V is how much? 9 volts. So current is how much? 1 ampere. So from here 1 ampere current will go. Now remember carefully. So 1 ampere will come here. Now if you see, 1 ampere comes here. So this is 8 and this is also 2448. So current will divide equally. So in this branch, 0.5 ampere will go, and in this branch 0.5 ampere will go. Now again, this 0.5 ampere here again divides itself into two equal parts. So 0.25 ampere and 0.25 ampere. So this 0.25 ampere finally will go here. So answer is 0.25 ampere will go into the 4 ohm resistance. So fourth option is correct. First is wrong, second is wrong. Definitely we can see in the first step only. Question number 41. While connecting 6 cells in a battery in series, see whenever you're connecting, suppose n cells are connected, right? And if one is like, if m cells are connected in reverse polarity, m cells, so E equivalent becomes n minus 2m into E. So sorry, this, okay, and R equivalent still remains nr, and current becomes E equivalent upon capital R plus R equivalent, right? So you will say n minus 2m into E upon R plus nr. Now just put the values. N is what? 6 minus 2 into 1 into EMF is 1.5 upon R is what? 24 plus small n is what? Small n is 6 into what is the resistance? 1. So it will be 6 by 30, that is 1 by 5 ampere, that is 0.2 ampere. Okay. 42. The maximum wavelength of a beam of light can be used to produce photoelectric effect on metal is simple. See, they have given us, see, we know that E is equals to work function plus maximum kinetic energy, right? So E is what? Hc by lambda. This is Hc by lambda naught plus Ke max. Okay. So from here we can say that maximum change in kinetic energy is equals to, now Hc by lambda can be written as 12400, okay, terms of electron volts, upon wavelengths in angstroms. So lambda is 2000 angstrom minus 2500 angstroms. In terms of angstroms we have written. Now if you solve it, you will get the answer 1.24 exact. Clear? Electron volts. What we have done is Hc by lambda, if you remember, this energy is also expressed as 12400 upon wavelength in angstrom electron volts, right? So in this term we have written it. Okay. Question number 43. The ratio of the de Broglie wavelength, see, lambda is equals to h by mv, right? So for proton upon alpha particle is equals to mass of alpha particle into velocity of alpha particle upon mass of proton into velocity of proton. Now mass of alpha particle upon mass of proton is 4 is to 1. Velocity of alpha particle upon velocity of proton, they have given us 1 is to 4. So answer is 1 is to 1. Fourth option correct. Got it? See, angular momentum remains constant. It is nh upon 2 pi. It does not depend upon z. L does not depend upon z. So if the orbit is same, n is same, then angular momentum is same. Got it? So whether it is the first orbit of hydrogen or first orbit of doubly ionized lithium. Okay. Here also very simple. You will say, sir, 1 by 40 is into 1 by n1 square minus 1 by n3 square. Similarly, 1 by 60 is equals to r into 1 by n1 square minus 1 by n2 square. So this is equation 1, this is equation 2. Whatever answer we need is this. 1 by x is equals to r into 1 by n2 square minus 1 by n3 square. So how we can get equation 3? We see that equation 3 is nothing but equal to equation number 1 minus equation number 2. So 1 by 40 minus 1 by 60. Answer will be 120. Okay. So ultimately you will say 1 by 40 minus 1 by 60 is 1 by x. Question number 46. Now to generate power of 3.2 megawatts. 3.2 megawatts. The number of fissions per minute happening. So delta n by delta t is the number of fissions per minute is delta n by delta t we need to find out. If energy released, okay, so this is what? This is the overall energy. This is number of, this is overall power. This is number of fissions per unit time into energy of a single fission, which is 200 mega electron volts. 1 electron volt is these many joules. Now one more thing is we need to convert this delta t into minutes. So multiplied by 60 also. Then now in this case we will get the accurate answer. Do you understand? So number of fissions per minute we wanted, now we will get per minute. Proper answer. Clear? See, if this was in second, so we know that 1 minute is 60 seconds. So what is 1 second? It is 1 by 60 minutes. So we wanted minutes here now. So this is how we will do it. Any doubt? What the number of fissions per minute? Per minute. If energy released in single fission is this. Absolutely correct. Okay. Oh, 1 minute, 1 minute, 1 minute. Delta n by delta t is already in minute. We need to convert it into seconds. 60 will be in the denominator. I'm so sorry. Because delta n by delta t is already number of fissions per minute. We need to convert that minute into seconds. So 60 will be in the denominator. Now I guess the answer will be correct. 1.6 ones are 2s are 2 ones are 2 100s are 1 0 will get cancelled. This will get cancelled. 10 to the power minus 18. So 6 into 10 to the power 18 will be delta n by delta t. Yes, now this is correct. Okay, delta n by delta t is already in minutes, number of fissions per minute. So that minute we need to convert it into seconds. So multiplied by 60 in the denominator, right? Now here, this is the formula. N square is equals to Ne into Nh. Put the values, get your answer. Okay, what is N? So you will say 1.5 into 10 to the power 16 whole square is equals to, the whole concentration is 4.5 into 10 to the power 22 into electron concentration. So after solving, you will get your answer. The ratio of the concentration of electrons to that holes in semiconductor is this. The ratio of the currents is, what is the ratio of the drift's velocity? I is equals to NEAVD. Okay. Ratio of the currents is, see, I1 upon I2 is equals to N1 upon N2 into VD1 upon VD2. I1 by I2 is 7 is to 5. Sorry, 7 is to 4. This is 7 is to 5 into VD1 upon VD2. Solve it. It is 5 by 4. Okay. Now here they are saying that this is a thermometer in which from the mark 0 to 100 degrees centigrade, what is the volume that needs to be occupied? See, if the mercury is at a mark of 0 degrees centigrade, and if you raise the temperature, it goes to a mark of 100 degrees centigrade. That means this is the volumetric expansion that happens. So this is delta V. So it is what? Pi by 4 into diameter is given 0.02 centimeter, right? 0.02 into 10 to the power minus 2 whole square into, what is the height, 30. Acha, the thing is we don't need to convert centimeter into meter because they have already given the original volume is in centimeter cube. So delta V by V is gamma delta T. So delta V is how much? Pi by 4 into 0.02 whole square into 35 upon volume is 2, gamma into delta T is 100. Okay, now you put the values, definitely you will get the answer. Clear? Correct answer will be the first option. Now 50th question. See, gas at a pressure of P naught is contained in a vessel. If the masses of all the molecules are C, we know that what is the kinetic energy? Half mv square. This is equals to 3 by 2 P naught V naught. Now, if you try to reduce the mass by half and speeds are doubled, right? So, if you say like this, if mass is halved, speeds are doubled, right? Volume is going to remain constant, so this will be what, 2 times half mv square. That means 2 times 3 by 2 p naught v naught. That means 3 by 2 into 2 p naught v naught. That means pressure is doubled, right? Got it? So these are the solutions to all the 50 questions, students, and I hope these solutions will help you a lot. Okay, so revise the topics which I have discussed here. Okay, so whatever questions have come up in this examination, pick up those questions and exclusively understand those concepts from the notes that you have been using to study so far. Okay, so this is how you're gonna completely strengthen yourself for the better preparation of your examination. Got it? That's all for today from my side. Thank you so much, students. Tada. Bye bye.